The generalizability of behavioral and educational assessment. One of the most difficult aspects of post-secondary education is the assessment of student learning. Faculty at all levels of post-secondary education must tackle the difficult problem of designing testing instruments to assess student mastery of topics, issues, concepts, and skills. How can faculty be assured that the tests they have developed will generalize to a broader set of topics, issues, concepts, and skills? One approach to establish the generalizability of educational assessments, and more generally the measurement of behavior, has been described by Lee Cronbach and his colleagues as generalizability theory. G theory has potential to provide reliability information beyond that obtained using classical test theory. Behavioral and educational measurement. There are many similarities between educational measurement and behavioral measurement, although many would argue that their primary distinction lies in educational measurement being subjective and behavioral measurement objective. However, how is it that behavior analysts are sure or can be certain that their objective measurement is consistent across conditions, across observers, etc.? The answer is reliability estimates, and reliability has firm roots in psychometrics and classical test theory. Classical test theory has long been the standard for establishing reliability estimates of observations, such as IOA, inter-observer agreement, establishing reliability for questionnaires, reliability for tests, and other assessment instruments. Classical test theory assumes that a score on a test or an inventory, survey, etc., contains only a true score component and a random error component, and that reliability is the proportion of true variance to the sum of true and random error variances. So we create a ratio there of true variance to the sum of true and random error variances. So that's the bottom or the denominator part of the proportion. True variance is the numerator. Classical test theory only addresses the relative standing of individuals. This is a very important point. What if teachers are also interested in how well a student knows the universe of subject matter, not how much a student knows relative to other students? Obviously, classical test theory is not adequate to measure this. The strength of G theory is that multiple sources of error in a measurement can be estimated separately in a single analysis. Therefore, G theory enables the decision maker to determine how many occasions, how many test forms, how many administrators, etc. are needed to obtain dependable scores. Dependability refers to the accuracy of generalizing from a person's observed score on a test or other measure, for example, behavior observation or an opinion survey, to the average score that person might have received under all the possible conditions that the test user would be equally willing to accept. For example, there is a universe of mathematics, and the teacher or the test maker would like to be confident that test scores on their particular test instrument will generalize to this universe. The definition of a universe is provided below in your handout. Absolute versus relative comparisons of student performance. Generalizability theory provides the researcher with a summary coefficient reflecting the level of dependability and a generalizability coefficient that is analogous to classical test theories. In addition, the researcher can investigate absolute levels of performance. In other words, what if we are interested in a student's absolute performance versus their performance relative to other students? Again, that very important point. G theory can statistically answer this question, where classical theory cannot. Academic standards involve establishing criterion levels of performance in academic areas. These areas can be general education skills such as mathematics and writing, or can involve skills more specific to academic majors. For example, what should students in the biology major know after 2 years of study at the undergraduate level? And how about at 4 years, which is the typical graduation? Standards of this type are being developed in post-secondary education across the country. A central issue in the standards movement is the decision, did this student pass the standard or standards? This decision could be comprised if generalizability and dependability are not clearly established. could be compromised if generalizability and dependability are not clearly established. In addition, the analysis of student performance must include both norm-referenced and criterion-referenced analyses. Otherwise, individual student learning gain will be lost in the analysis of comparing one student to another. The academic standards or criterion judgments about individuals is not part of the classical test theory of measurement. Only relative judgments about individuals can be made. To use the biology example from above, the task is to define the universe of biology for sophomores at the 2-year level, at the end of their sophomore year, and for senior students, or the end of their senior year when they graduate from a biology major. A universe of content, knowledge, skills, and abilities. Does it really do the educator any good to know that student X scored 15% higher than student Y on a standards or a criterion referenced test? I would say not really, especially when compared to knowing what percentage of the biology universe does student X know, regardless of student Y's performance. Generalizability theory is able to incorporate criterion judgments about individuals, primarily through the definition of a universe, whereas classical test theory cannot. Generalizability studies. There are essentially 3 steps involved in establishing the generalizability of a test score. First, the universe of generalization must be identified. Second, tests and assessment instruments must be designed to test for generalization. And then third, test scores are analyzed in terms of a variance component, or variance components, in order to establish the generalizability or lack thereof to the identified universe. The second and third steps are relatively not difficult to complete. However, identifying the universe of generalization can be extremely difficult. The previously mentioned trend in post-secondary education, namely establishing academic standards, can alleviate many of the problems inherent in an attempt to identify a universe of generalization. Academic departments on the University of Nevada, Reno's campus and many others nationally are establishing academic standards for all majors within their discipline. This involves the identification of both content standards, for example, the knowledge of facts, names, categories, taxonomic classification systems, as we mentioned, as part of any science. So those that are in a science major will talk about those in terms of content. And then process standards, which involve critical thinking, reasoning skills, and higher order skills, which are the least clear in their current definition. These standards can be translated easily into the language of a universe of generalization. For example, the test scores from assessment instruments developed by teaching faculty in the curriculum for a particular major should generalize to the academic standards of the major, as identified by the faculty. It should be noted that the entire universe is not necessary to define, but rather the universe you are trying to test should be the goal for identification, with the caveat that there will be additions, deletions, and quality improvements to the universe as currently defined at any given moment. In other words, as almost all of us accept, the content of our disciplines is dynamic and far from static. Statistical acceptance versus theoretical acceptance. As one might expect, generalizability theory, as with almost any psychometric theory, there are quite a few mathematical formulas, variance components, and coefficients to be considered when actually conducting a generalizability study. However, after the initial reintroduction to some of the basic concepts of reliability, which are taken for granted in the behavior analytic community, the theoretical position behind generalizability theory is much more in line with that of behavior analysts. In addition, generalizability theory is an extension of classical test theory, and the psychological community should incorporate this theory into practice, as it has clearly been demonstrated to provide more relevant information. Regardless of one's willingness to utilize the statistical applications of the theory, there is no justification for throwing the statistical baby out with the bathwater. Perhaps there are some points of agreement in theory and practice that can align the behavioral conceptions of generality, measurement, and observation with those of a more psychometric, theoretical background. This calls for a reevaluation of our methods for conducting IOA estimates and other coefficients currently utilized to determine reliability in behavior analysis and in education. The reliability and generality of data. Murray Sidman begins his book, Tactics of Scientific Research, Evaluating Experimental Data in Psychology, with a description of 3 criteria by which data are evaluated.